So lesson 8 has us looking at our zeros a little bit more intensely and figuring out how we can use our zeros of a polynomial function. So not just finding them, which was what lesson 7 was about, but how are we now going to use it. So we have one example, actually we have two examples that should be part of your packet. We're going to go through your first example right now. And in example 1, I gave you guys a coordinate plane off to the right hand side, and the directions for example 1 ask you to write a polynomial function of least degree that has real coefficients, the leading coefficient of 1, and negative 1, 0, and 2 as your zeros. So let's try to cut up these directions and try to make sense of what's being asked of us. The first is we want to come up with a polynomial function, so something like a cubic or a quartic or a quadratic, a polynomial function that has real coefficients, so real numbers, not imaginary numbers that are going to be in front of my x's. Our leading coefficient, that's 1, which means whatever x value we have leading, whether it's x squared or x to the third or x to the fourth, that leading coefficient is 1. And we have 3 zeros. Right off the bat, you know if you have 3 zeros, you're going to be looking at a cubic, or probably a cubic, especially with real coefficients, a cubic function, because you have 3 x values here. So, pulling out the information that we want, the first and most important information is what our zeros are. So you know that your zeros is x is equal to negative 1, you know x is going to be equal to 0, and you know x is going to be equal to 2. That's given information. We know that those are our zeros. From our zeros, we can extract what our factors are. So we can pull out what our factors are from this information. If x is equal to negative 1, we know our factor for the first one is going to be x plus 1. If we know that we have x is equal to 0, we obviously know that we have x plus 0 as our factor. And we also know that we have x is equal to 2, we had x minus 2 as a factor. So from our zeros, we can pull out what our factors are. A couple quick things is x plus 0, obviously is the same thing as just x. So if we wanted to, x plus 0, that can be its own group. At this point, we want to come up with the polynomial function that has these groups as your zero. So we want to come up with the expanded version. We want to have something like x cubed plus or minus something, so on and so forth. So we want to come up with the expanded polynomial function. So we take our 3 groups that we have here. Since there are 3 groups, we need to pick 2 of them, and we need to multiply them through. So the first 2 are the 2 that I'm going to multiply through. And then whatever I get as my answer, I'll just multiply it with my last and final group. So if I FOIL or distribute my groups here, x times x is x squared, and 1 times x is a positive 1x. So when I multiply those 2 together, I get x squared plus 1x times, obviously my second group is still left over. Since I have 2 terms here times 2 terms here, I'm going to be able to FOIL. And you guys remember FOIL as being your first numbers multiplied together, your outer, your inner, and your last numbers. So if I FOIL my 2 groups together, x squared times x gives me x cubed. X squared now times minus 2 gives me minus 2x squared. So first, outer, inner gives me plus 1x squared, and then last gives me minus 2x. When I go through now and I combine my like terms, I get x cubed. My negative 2x plus 1x squared, because they're common terms, I get minus 1x squared, or just x squared, minus 2x, which I have left over. This is my final answer after I multiplied everything through and combined my answer. So now I just need to put my f of x, which is basically just my y value, out in front. So f of x is equal to x cubed minus x squared minus 2x. And that polynomial function has real coefficients. Real coefficients mean that they have to be real numbers out in front of my x's. This is 1, this is -1, this is -2. All of those numbers are real numbers. My leading coefficient of 1, my leading coefficient, since my degree is 3, that invisible number in fact is 1. And all three of these zeros, if I went backwards and factored them down back to zeros, I would get x is -1, x is equal to 0, and x is equal to 2 as my zeros. I had 3 of them originally, and I ended up with an x cubed, so it should all work out really well. At this point, those zeros from the directions, I can graph my final equation or function and get an idea of what this looks like. And I do that by knowing what my zeros are. So since I know x is equal to -1 as my first zero, x is equal to 0 as my second zero, and x is equal to 2 as my third zero, those points on my graph represent those zeros. Since it's a positive leading coefficient, I know that my two arrows should be connecting to give me a positive slope. So my arrow should start in the downward position off to the left and rise to the upper right-hand position to the right. So if I do that, I should get something that looks similar to that. At this point, you guys can work on the Now You Try number 1. You're given the same type of directions that you were given for example 1, so you can use example 1 to build on the answer that you get for the Now You Try. This will be part of the homework that will be collected the next time we see each other in class, so make sure you have that ready to go the next time we get together. In the last and final video in this folder, we'll talk about example 2, and you'll be given some time to work on number 2 Now You Try for the next time we get together for class. If you have any questions at this point, you can email me, or you can make a little side note in your notes and highlight some questions so that when we do meet next, we can summarize what Lesson 8 is all about and make sure that all your questions get answered. All right, in the next video, we'll talk about example 2.